Good morning, everyone. Welcome to start a webinar series by Managed Center for Innovation and Agripreneurship. Give us a couple of minutes, we'll be starting. Meanwhile, I request speakers to check with your applications. Good morning, everyone. We'll be starting now. So welcome to start a webinar series by Managed Center for Innovation and Agripreneurship. This series we have been doing for more than 1.5 years. October 2020 we have started. We have Managed Center for Innovation and Agripreneurship has incubated more than 300 startups and mentored them. So across multiple focus areas. Today's topic is IoT-based agri startups. We are having 3 founders today with us today. I would request Sailendra Singh from Uctix Technologies to start. They're one of the leading IoT-based solutions for agri-tech sector. So he has a wide experience in that. He is with our ecosystem. Sir, can you share, sir? Sir, you can start, sir.
Screen visible.
Sir, you are on mute.
Hello.
Yes,
Yes, sir. Yes, sir. It says starting to
No,
share
I
the
think,
content. Give us a
Can you
moment.
hear
It
me?
may
Because not mute. System is not. Yeah. Okay. Okay. Yeah. Sure.
You can probably share again, sir. It may taking some time now. Now, yes, sir. Yes, sir. I can see now. Everything is fine. You can start.
Okay. Okay. You are able to hear me properly, right? Sir, you are able to hear me properly?
yes, sir. We can hear you very clearly.
Okay. Okay. Thank you, sir. Thanks for providing me an opportunity to share my views on IoT for agricultural startups. I'm Shailendra Singh, and I am a co-founder at Uctix Technologies Private Limited. Let me just give you a small introduction about Uctix Technologies. We are a IoT-based startup. We are developing agri intelligence for crop using the power of IoT and AI. And when I say AI I will focus more on the data analytics part and the statistics part. AI is quite complicated term. Sometimes it will be very much difficult to even explain what AI actually do. People have published their thoughts on what means how much of AI we are able to use in these days. I come to the I'll come to the topic that I'll start with smart farming. Smart farming is the umbrella term which everybody is using, and under a
Sir,
smart farming there
apologies
are
for
multiple
interrupting, sir.
sectors. There.
Sir,
Yes,
apologies
sir.
for interrupting. Your voice is cracking, sir. You may switch off your video if there is issue with network.
Sure. Just a moment.
Okay, okay.
Okay. Now is it better?
It's far better
Yeah.
now, sir. It's far better.
Okay. Sorry, I am a phone network. I'm still in my home. I have to go to office at some time. So
No issue, sir.
there
Thank
might
you,
be
sir.
whenever there is a lag, you can let me know.
Please, please, sir. Please carry on. We are here for everything.
Yeah. Yeah. So smart farming has multiple vectors, has multiple verticals on which people work, starting from image analysis. And again, image analysis can be done on the image captured by satellite or image captured by drones or image even captured by the camera. There are multiple companies who are focusing on specific sub verticals also. There are companies who are utilizing images captured by the captured by the satellites. There are certain companies, not in India specifically, but there are companies outside India who are focusing on analyzing the images captured by drone with a camera. And there are certain companies like Plantix who are very much focusing on the analysis of images captured by the phone itself, right? Then the second sector is IoT, that is Internet of Things, on which I'll be focusing after this slide. Third vertical is soil analytics. So there are companies who are analyzing the soil using different kind of spectroscopy, different kind of lab-based method or chemical method. Uh, then there's another vertical which is called blockchain, where companies are focusing on tracing the assets from how they are moving from one location to another location. And then there are companies which are only focusing on the data part, that is AI, ML, or big data or data analytics. And these days, most of the companies are building up, most of the companies are building up a platform where they are probably providing every kind of technology, whichever is available in the market. Talk about Deha, talk about Gramophone, talk about AgroStar. These three are the biggest company who are developing the platform where they are providing every kind of advisory. That can be image analysis, that can be IoT or soil analytics, blockchain data. So smart farming itself is a very big vertical in which there are multiple parts. And in today's presentation, I'll be focusing on IoT. Sir, is there any time limit? So I'll be focused upon that so that I can finish my presentation in a defined amount of time.
Yes, sir. 30 minutes for each speaker, and after that, post
Okay.
question and answer session for 30 minutes.
Sure. So, okay, it's 11:08. So I'll try to finish it by 11:30. So when we talk about IoT, that is Internet of Things, there are basically three components in that, and I'll be focusing more on technology side. Business side question we can answer in the last. So in the IoT part, there are basically three components. The first component is agriculture sensor, means agri sensor, which can be micro weather sensor and soil sensor. And here I am trying to focus only on the pre-harvest side. In agriculture also, there are pre-harvest, there's post-harvest, then there's processing, and then there's connect to market. So I means here the first component is the sensor, which sense the physical variable in the field. These physical variables can be temperature, humidity, pressure, rainfall, wind speed, wind direction, solar radiation, soil volumetric water content, or normally soil moisture, soil EC, soil pH, and there are other variables also which can be monitored. These physical variables can be images captured by the phone or images captured by the camera. The second component is the IoT device itself. Means IoT device. So sensor is very much different. Standalone sensor cannot provide the user the value which he can use. So sensor need to be integrated with a device that we are calling as a hardware or IoT device. Now these IoT devices can be micro weather monitoring weather station for smart irrigation, for insect counting, or a camera, automatic camera. The third part of any IoT system is the software part, using which the user get access to the data, whatever data is being captured from the field. The software can be deployed on the browser, the software can be deployed on the Android phone or any other smartphone. So these are the three components of any IoT of any IoT system: sensors, devices, and the software part. I'll deep dive into this again in the next slide. So again, I will try to drill deeper into this. So when we talk about hardware part, sensor. So as I mentioned in my previous slide, these sensor are the component of IoT system which measure the physical variable which are in the field. And I have mentioned about what kind of physical variable can be monitored. Apart from that, GPS is one more device that using which you can monitor the location of a specific asset, right? Soil pH, soil EC, soil turbidity, then soil and then water turbidity, water temperature. Although water sensors are quite complicated. So the first part of that was the IoT sensor and the IoT. So you have sensor, then you have hardware. So hardware is something. So people who are from the electronics background or people who are from the software background, they will understand hardware is more like your computer hardware. In fact, your computer also have multiple sensors. Your computer has inbuilt RTC. Your computer has inbuilt temperature sensor. If you go to any Windows platform, you can look at, okay, what is the temperature of your CPU? So how that is monitored? You have a sensor installed inside your CPU. So this is the hardware part. Hardware part, you integrate sensors to the hardware. Then you have firmware. Firmware in our ecosystem is a software, a small piece of software. For example, you have the CPU have some kind of OS, operating system. So very smaller version of that software is installed on the hardware. Then in any IoT hardware, there's one very important component, that is communication module. How do you transfer data from that hardware to a remote location? Because that is the basic promise of IoT, is Internet of Things, that you are enabling devices with internet so that you can assess the information captured by the devices being in any remote location. So the hardware part has sensors, it has hardware, it has firmware, it has communication module, and how it can be useful for you whenever you are developing any kind of IoT devices. You should be aware of this thing, that IoT devices will have these part. The second component is IoT cloud, device and data management. So the first part is completed. You have sensor, you have hardware, you have done firmware, you have a communication module. That can be GPRS, that can be Wi-Fi, that can be Bluetooth, that can be Ethernet, that can be sub-gigahertz communication, as in the local wireless communication. But what then? So there has to be IoT cloud which can manage these devices. Now, if the people can ask, okay, why IoT cloud? Why cannot I host this information on a simple database? So it become quite complicated because because the data coming from one device, somebody can easily manage. But what if you have deployed 1,000 devices or 10,000 devices? Then you need to have a management layer which can help you manage these devices. How many devices are there? Where they are deployed? How many of them are off? How many of them are on? Is the sensor malfunctioning somewhere or not? So there are multiple component of IoT cloud also, that is THDP, time series database. There's a normal database which help you manage the users. There's a worker management, how many processes are working on the back end, how many sensors are data is coming, how you are transforming them, how you are computing them. Are you doing any other kind of process? So if there is some sensor data where you are transferring, if it is image data, where you are transferring it. So that is second part. Third part is API machines. So you also need to distribute this data to multiple other machines for the processing part. Fourth part is computation, what people call as AI, artificial intelligence and machine learning, report and alert. So, okay, IoT devices help you to collect this data, but how you can transfer this, how you can transform this data into something that a farmer can understand or that a user can understand. A normal user will not understand if you tell him that this temperature is moving like this. What he will do? He need to get some actionable insight out of that data. That if temperature is moving like this, how it is going to impact any process in pre-harvest or post-harvest, or in processing, or in the current to market. For example, if a user is transferring potatoes from his cold storage to his processing processing factory, and if the potatoes are supposed to be in a specific temperature range, so you need to monitor that, okay, are during the transport were the potatoes exposed to any temperature range which was not desirable, because it can affect their quality, right? So this is what user want. Has there been any incidents where temperature has gone outside the desired limit? The fifth part is the front end part, basically web browser, smartphone application, using which the user will assess all this data. So this is a bit more explanation about the IoT component. So as I was talking to you, explaining earlier, this is the hardware part. So you can see on the left hand side, these are the devices. This is the actual hardware. This is the actual hardware. Just a moment. This is the actual hardware which we use. The second photo on the right hand side is where we have kept this hardware inside a box. The third photo on left hand side is where some of my colleagues are encoding these devices with the firmware. And the fourth photo on the right hand side bottom is the manufactured devices, how they look after everything is done. Sir, am I audible? Is there any problem? Am I going too fast? Or
No,
is
sir.
this fine?
Perfectly audible.
All
Yeah,
good and
thank you.
suitable, sir. Please carry on.
Thank you. So this is just to tell people, okay, how does this hardware look like? Okay. Uh, then this now coming to the IoT application in agriculture. So there are multiple verticals where the IoT can be implemented. For example, as I mentioned earlier, that at least I see this thing agriculture in two parts. One is pre-harvest and second is post-harvest. So in pre-harvest, IoT can be implemented for irrigation. IoT can be implemented for disease and pest forecasting. IoT can be implemented for soil management. Soil management can be a part of irrigation itself. IoT can be implemented for weather forecast. IoT can be utilized for image-based processing. You can have these solar-powered cameras, which are totally automatic, which keep on capturing the photos from the field. IoT can be used for scouting, as in when some farmer is going around his field, he can capture multiple things. IoT can be utilized for asset tracing, where a specific asset is in the pre-harvest stage. In the post-harvest, IoT can be utilized for cold storage monitoring. IoT can be utilized for hydroponics, in aquaponics, and vertical farming. IoT can be utilized in livestock, in dairy and farm machinery monitoring. So these are few application in which IoT can be applied. I'll try to cover individual one of them. This is again one very simple illustration of how the IoT is being implemented in the pre-harvest stage. So you can see the downside, the right-hand side, bottom right-hand side. You can see there are certain devices which are deployed, which come with certain sensor like soil moisture, soil temperature, or even lux, air humidity, air temperature. So these are small sensor nodes. They can communicate to a gateway. Means uh, so so there has been instances when you go to a field and farmer will ask that, can my field is 50 acre, and will a single device will work? So the answer to these kind of question can be complicated. So in these cases, we usually deploy small devices which communicate to a gateway using wireless communication, using local communication. For people who are not from the field, they would have seen the walkie-talkie. So how the walkie-talkie talk to each other. So you can just correlate this thing, that these are small walkie-talkie with sensor. So one walkie-talkie talk to another walkie-talkie, and the another walkie-talkie has a SIM installed, which has the internet access. So from there, data goes to the cloud, right? So this is more like a pre-harvest application where you have sensor installed, data is collected from them from multiple location. Then you have a weather station. All this data goes to a cloud where it is processed and it is presented in front of farmer in a manner which he can understand and which he can use in his daily operations, right? A farmer start from the morning and he do hundred of activities in a single in a week, right? So how you can help him to increase the efficiency of his operation? How you can help him to optimize the resources which he is using on daily basis? Can you help him reduce the amount of water which he is using? Because excess water can definitely impact the plant, or water stress can definitely impact the plant. So you need to optimize the use of water. You need to optimize the use of fertilizer. You need to optimize the use of sprays also. So this is just an explanation about the pre-harvest. Then is smart irrigation. So again, smart irrigation is again a complicated. It's not complicated, but there are multiple parts in the smart irrigation also. So there can be local control, there can be remote control in smart irrigation. When I say local control, what I meant is that it can be a flow based control, it can be sensor based control, it can be timer based control. So you can have a flow meter which will keep on measuring that how much water is going into the field, and you can have a IoT device in which you can encode, you can write a software which will keep on monitoring that, okay, if the amount of water flowing through flow meter exceed this limit, turn off the flow meter, turn off the motor. So suppose you want to irrigate, just example, you want to irrigate a field with 100 liters of water. So you will have a device in which you will write a software that whenever the data from flow meter tell that 100 liter has gone through it, turn off the motor. So that is a local control. Nobody is controlling it from remote location. Similarly, sensor-based control. You can write a software which will keep on monitoring the sensor values. Whenever the sensor values goes above a specific level, that's mean the field has been irrigated, and you can again turn off the motor. Similarly, third is timer-based, which people usually use. Most of the people usually use that you simply turn on the motor for 15 minutes, because you know that, okay, in 15 minutes this much water can be given to the field, because you know how much HP is the motor. So these are some local control smart irrigation. Why you are calling it smart? Because it don't involve manual intervention. Second part is remote control. In this, most of the people would have heard about Kisan Raja. Uh, so they have something called TTMF based or IVR based remote control system, in which you call some number, you press some buttons, 1, 2, 3, 4, and based upon that, the controller on the other side turn off or turn on the motor. Then there are a few systems which also use SMS. So SMS I will also keep into the DTMF, or basically mobile phone based, where you send a SMS to the other number. The IoT hardware on the other side, which come with a GPRS module, read the SMS, analyze it, what kind of command is being sent, and then based upon that, it take the action. The most interesting thing among the remote control is the internet based, where a lot of interesting thing can be done, where you can schedule at what time irrigation need to be done, where you can monitor what is the sensor value. You can just toggle a button and it will turn off the motor in the remote location. So this is some information, or some information about the smart irrigation, which is divided into two part, local and remote. This is another example of smart irrigation, where you can have plot 1, plot 2, plot 3, plot 4. You are transferring data from plot 1 to a sensor data receiver, which I was talking to you earlier, walkie-talkie thing. So plot 1 to gateways to cloud. So you can access all this data, that what is the value of plot 1, plot 2. You can have a local gateway. So here you can do both the things. You can have a hybrid model where control is done locally, but you are able to access all this data. So this is just a small illustration to tell people, okay, how it can be done. And it is being done in multiple locations all across the world. In fact, in India, in fact, we have done this kind of system implementation in multiple locations. This was one of the video where let me see if I can run this video. Yeah, this is one video, one small video of our deployment of soil moisture monitoring in a tomato farm in nearby Bangalore itself. I think it's taking some time to buffer. So I'll move to second slide. This video is accessible on our YouTube channel. You can go and you can look over there because we are running out of time and I want to finish the slides. So this was just one example. This is another illustration of post-harvest monitoring, where you can have these devices installed inside the deep freezer or in the shipping containers or in the refrigerated trucks or in the silos or in the cold storage. So these sensors can be temperature, humidity, or in some cases it can be ethylene-based sensors which monitor the ethylene or which monitor the CO2 levels. And again, then there are multiple communication options starting from GPRS, Wi-Fi, Ethernet. In India, satellite communication is low Earth, that is called low Earth orbit, LEO satellites. So they are not allowed. But if you go outside India, satellite communication is possible. It can be GPRS. So again, same concept that you have sensor installed in different location. There's a IoT device with a communication module. There's a cloud, and then you have a application in which you provide the actionable intelligence to the user. In post harvest, most of this actionable intelligence depend upon the alert. Okay, if the guy who is into warehouses, is he maintaining the proper temperature ranges or not? Ma'am, it will be difficult for me to talk in Hindi because again, right now I think English is the common language. So this is again another example of our deployment, what we did long time back for the cold storage. This was what we call is a cold sense. So you can see this is totally a battery powered device with local wireless communication option. So all these devices were battery powered. They were communicating to a gateway which was outside, because inside the warehouse you won't get any GPS signal. So these are again complicated points. So again, coming to the post-harvest again, asset monitoring, you can monitor your assets deployed in the field using combination of GPS plus GPRS. Now monitor where the assets are they utilized properly or not? What is the fuel? Is somebody stealing the fuel from the machines because it actually happened? Who is a user who is using that asset? This asset can be a harvester, tractor, thresher, power tiller, or trucks for transport of agriculture produce. So again, this is one another example of how IoT can be utilized in asset monitoring using with a combination of GPS and GPRS. This is another example of the same asset-based monitoring, where you can have GPS, fuel level, driver identification, machine health. So the concept is again same, that you have sensor, you have IoT device, you have cloud, and then you have some actionable deployment, actionable insights for the user. This is another example of IoT for hydroponics or vertical farming. In hydroponics or vertical farming, mostly into hydroponics, people ask that, okay, what kind of sensor can we use? And to be very frank, all these sensors which are used to monitor the quality of water are quite complicated, because these are chemical-based sensors, and chemical-based sensors are not always that good. The accuracy is quite low. Right. So, but still there are some sensors which can be utilized inside the hydroponic setup or vertical farming. The sensor are temperature, humidity, lux, CO2, wind speed, or water pH. Water pH I will avoid using, because most of the sensor which are cheap are not good quality. So you always need to maintain a balance between the quality and the cost, right? You can have cheap quality sensor, but you cannot trust on them because the accuracy of those sensor will be very much less. So again, the concept is again same here, that you have sensor, you have devices, you have cloud, which run your analytics for you, which run reports for you, and then you display all this information back to the user. This is more like on the technology side. That what are the I have gone through this earlier: sensor, devices, cloud, and then actionable intelligence. This is simply an example of our dashboard, how we have done. Inside a greenhouse, you can see our devices. These are the devices which we are deployed outside in the remote location for the people who are into agriculture field. Again, some more deployments. This is again this gigabits, what we have defined as gigabits instead of green sense for the open field monitoring and smart irrigation. Some more photos, some example of how we have done the multiple location soil moisture monitoring. Some more example of deployment in a vineyard, some more location. Sample is screenshot of our dashboard and some more photos. I think I have run out of time, so I won't be able to go on to this case study. But this case study, we have deployed the IoT system from starting from seed to factory, from where they were multiplying these seeds using tissue culture to cold storage during transport, during pre-harvest, and then from field to the factory. So that's it from my side. I think I'm on time. Sir, over to you.
Thank you, sir. Thank you very much. There are a couple of questions that we will taking at the end as a panel. So there is a request that to be speak in Hindi, as everybody knows that we have users across India. So what we can do probably in question and answer session, you can utilize that in local languages, ma'am. That's not an issue. Thank you, Sailendra sir. We'll move to the next speaker.
Sure.
Our speaker today, Mr. Samlal Shashi, is the founder of Budmore Agro Industries Private Limited. So they are part of managed ecosystem. She is supported under RK Raftar program. So is a trainee as well as incubator with manage. They're reimagining and designing smart solutions using IoT for aquaculture related aqua sector and related to that. So they are addressing very big problem in the aquaculture sector. So on this note, we welcome Shyam sir. Sir, can you hear me?
Thank you, sir. I can hear you. Good morning, everyone.
Yes.
My name is Shyamlan Shashi. I'm the CEO of Budmore, and today I'll be explaining about our products, services, and how that could be used in the aquaculture sector. And due to the bandwidth issues, I would better turn off my video before I start with my presentation, so that the message gets conveyed to the audience clearly and properly. Beginning with my presentation. Hi. As I've told you, Budmore is an agriculture technology company focusing on improving the aquaculture productivity using technology. Meanwhile, we make sure that the sustainability and eco-friendliness of our product with nature is always complied with. And coming to the bigger view, the problem statement, the problem that we have been trying to solve, or we have been trying to address, is the lower productivity in the aquaculture industry, the global aquaculture industry, and also the Indian aquaculture industry, and the reason for that productivity. We can understand that the higher in some species like prawns, the issue is the mortality issue is so severe that sometimes they experience 100% mortality. Probing on the causatives, the prime reasons are the inferior water quality management, unstructured growing practice, and infections. This is what we could understand from our surveys and the data that we collected from various organizations, government and non-government organizations. The solution what we offer is a smart farming solution and a smart disinfection solution. Smart farming solution is what I would be talking right now in this PPT, in this presentation, in this webinar. And Budmore smart farming solution is a combination of your IoT hardware and one cloud-based farm management system. And prior to we get into what our automation solution or our IoT hardware and the farm management system does, I would request, I would like to explain the core activity that happens in an aquaculture farm. The primary activities that happens in the operations that happen in an aquaculture farm is the feeding, which is the most important part. Then is the water quality monitoring and water quality management, aeration management, circulation management, power management. Power management is very critical because in case of high density aquaculture farms, once there is a power outage, it can lead to mortality within a couple of hours. And lastly, the security surveillance. And wherever there is a large-scale production in India, we have susceptibility to threat and burglars. So we also have included the security surveillance aspect into our products. And how the whole process happens. And we, as I have told you, what we have done is we have tried to understand all the processes that are happening inside the farm, and we have tried to automate each and every process that is being manually done in most of the farms nowadays. And how we have done that? We have a set of 7 different controllers and 1 communication controller. That too is another controller. The 7 different controllers which automates different functions communicates with the communication controller, which in turn communicates with the farm management system. The communication controller has a couple of ways in which it could communicate with the internet or the cloud-based farm management system. The most preferred way we would suggest is the Wi-Fi. The next is the SIM-based GPRS communication, and the last one is the wired communication. And we have around, as I've told you, we have 7 different controllers. The first one is a water quality controller. The water quality controller receives input from the water quality monitor. We have a couple of water quality monitors in sales right now, and the most complex one is a multi-parameter water quality monitor, which accepts 5 different sensors, and it takes 6 different readings. And that water quality monitor that has industrial grade sensors, which fetches the water from which particular water quality parameter from the water, sends it to the water quality controller, which intends communicate it with the rest of the controllers like the circulation controller, filter, and the aeration controller. If that whenever there is a dip in the dissolved oxygen value, the water quality controller asks the aeration controller to quickly resolve that issue, and the aeration controllers controls the connected loads like the primary, secondary, tertiary aerators, and it ensures the aeration controller controls loads in such a way that no load is being utilized. Every load is functioning in the optimal manner. At the same time, the threshold breach is being addressed quickly. And similarly is the circulation controller. Whenever there is a dip in the other water quality variables like the ammonia, pH, electrical conductivity, or there's a difference in turbidity value, then the circulation controller sends signals to the circulation system and also the filters associated with it, which make sure that the water quality is brought back to the optimal state. And there are other mechanisms like drawing in addition to the circulation process, there are other mechanisms like drawing in fresh water and pumping out the polluted water. And the filter controller, what it does, it senses the load and also the dirt accumulation inside the filters, for instance, the drop filter and the pressure sand filter. And it does the backwash and also the load balancing of these filters, which generally are the higher load equipments in our RAS system or a high density farming system. That controls the feeder controller. The feeder controller, in fact, sends signal to the feeder mechanism to dispense the feed at precise intervals as precise quantity. based on the total biomass holding in the particular pond at that particular time. Security controller senses intruders, and it is capable of triggering alarms, and also it is capable of controlling the lighting systems so that the owner or the concerned authority is notified immediately. And the power controller, the most critical part thing that has to be observed and managed in a aquaculture farm, which as I have told you before, is a power. Whenever there is a power outage, the power controller switches the power from the primary power to the secondary power. That is the primary AC power to the generator power. And in situations when there is a no generator power, it also has the input options for an inverter power. So this particular controller toggles between all these three things and make sure that whenever there is a crisis, that it has been managed, and also triggers alarm to the user, so that user also get to know that there is such an issue in the form. This is a whole process. This is a whole process that explains how things are done using our current product. The current product line, as I've told you, is a series of 7 different controllers and 3 different types of water monitors. There is a power monitor, water quality monitor, and the automation display. These are all the products which are in sales right now. And coming to the whole system, the smart farming solution, as I've told you, the IoT hardware would be taking care of all these activities, which would be done. The hardware which I have told you right now has logics written into its programs, which is capable of functioning online and offline. In case of offline functioning, the hardware would function based on the logics that are being coded into the hardware, and there is a different mode in which all this hardware is capable of functioning, which is known as the FMS managed mode, wherein the centralized software, the farm management system, would be controlling the hardware. That's the IoT part of it, remote management. The functionalities of the hardware, like the different hardware that are in the IoT component, I have already explained a few minutes back. And coming to the FMS part, the centralized software, which right now receives data from all the controllers across all the farms which are functioning right now. And it would be the remote controlling aspect. We have rolled out the first release, and it also includes FMS also includes other modules like crop management, like how a farmer has to the software will assist a farmer from the beginning of a crop deployment till the harvest, and all the primary activity, that is a feeding. And that software also takes care of the feed inventory management and the dispensing. The feed inventory will get reduced based on the feed that is being dispensed by the smart feeder. And the previous presenter has told, there is no use, like there is a lot of data flowing in from the IoT sensors, devices, etc. to the cloud system, and unless and until these data are being properly analyzed and given to the farmer in a way that a farmer can understand, these data are of no use. So what we do is the advanced BA analytics part analyzes the data that is being pushed onto the server and provides actionable insights to the farmer, who could just read the insights and perform the action to maneuver the particular threshold. And this FMS also has an AI/ML part, which analyzes the data which gets accumulated onto this database over the period, and helps in predicting a couple of things, which would be explained in subsequent slides. And as I've told you, these are all the products which are in sales right now. Version 3.4 hardware. It's a combination of 7 different hardware and 3 different monitors. And I have classified, by saying monitors, I have classified the water quality monitors, the single parameter and the multi-parameter, as one entity. Coming to the product overview, how the product looks like is inside a metal box. All these different controllers would be kept, and these controllers are capable of working in standalone system and also in combination with each other. This is a view of a real automation system that was shipped, exported recently. And this is the combination works as a single system, full farm automation system. And it's version 3 hardware. This actually is the farm management system. I'll please be on hold. I'm waiting for the browser to get. Locator is a farm management system that we have right now. That's the version 1 of the hardware. This is our own farm, which is pushing the data right now. The current hardware, the current software is undergoing a series of changes, and because of which it takes some time to load, but yeah, it takes. These are the readings that are being uploaded, like the temperature, AMO is ammonia, SA is a salinity, DO is the dissolved oxygen, pH. These are all the statistics of the load that are connected, like the aerator, the water level in different ponds, the working of the aerators, the primary aerators, secondary aerators, filters, etc. This is how the UI would look like. This is a version 1 of the farm management system. The version 2 is actually in production right now, in development. And coming to the next version of product, which is almost, I should say, it's almost ready to be sold, would be something like this. Instead of the 7 different hardwares that are in sales right now, we would just be having 2 hardwares, just the BMIS, the Budmore all-in-one automation system, and the water quality monitoring system, which would would both have the same user interface, everything same. But the Budmore for the first one, the automation system, would have a couple of additional features in comparison with the existing product line. This is the pictures directly taken from the R&D records, and this, it wouldn't be like this. There would be a shell to it. There would be a casing for the product. Coming to the AML part, that we have integrated right now, that our team is working on, is the productivity optimization and the FCR analysis and prediction part. And we are using modeling algorithms like incremental decision tree or neural networks, along with additional information at later stages. And later stages would also be using neural networking algorithms to predict the issues, the pressing issues like algal blooms, disease outbreaks, unpredicted mortality, and decline in FCR, etc. The collaboration that we have right now, we have a couple of. We know that in order to achieve higher speed and progressiveness, we always have got into synergic collaboration with partnerships with peer companies globally. These are the listed research institutions and partner companies we collaborate with. Officially, these are our partners. And these are all the people who are on board, the real team behind Budmore. And thank you. Thank you, everyone. Merry Christmas and a very happy New Year. And we are open to questions. I think, as per what you guys also told, we would take up the questions once all the 3 participants have completed with the webinar. Thank you for your patience, everyone, and Merry Christmas and Happy New Year.
Thank you very much, Shyam sir.
Thank you, sir.
So, for sharing your company details. Next, I'll move to the next startup, Sanket Kedar. Sanket, can you hear us?
Yes, sir. I can hear.
Okay, thank you. Sanket is running a company, True Farm Technologies. They are working on IoT-based solutions for horticulture-based crops. They are based out of Nasik, Maharashtra. So he's a part of managed startup ecosystem where we supported under RKR After. Sanket, you can start your presentation, please.
Thank you. So my name is Sanket Kedar. I'm founder of True Farm Technology Private Limited. And we are working in farm monitoring system. So is it visible to you?
Yes, it is visible, sir. You can just make it full screen and start slideshow.
Okay, now it's slideshow. Is it okay now?
Yes, sir, you can start, sir.
Okay. So basically, we are working pre-harvesting. We are also supported by Manage. So why we started? I belong to a farming family. My father is farmer. So basically, it started from our own farm. So whenever I get a time from studies, I was helping my father on the field. So whenever he shared his experience with me and his other friends, they were always complaining about the farm yield they got and how much effort they are putting into the field. So basically, every year they were using more fertilizers, more pesticide, more everything, but they are not getting increased in compared to their efforts. So after that, I personally interviewed more than 100 farmers across Maharashtra to know the real pain point or cause uh, for the low yield or for the low yield and less productivity. From their interviews, I came to know that almost most of the farmer are using their experience from their own experience, advices from their fathers or other colleague farmers. Then the second is most of the farmers are using crop consultant to help them on the field. Then only 2% farmers were using mobile applications. 3% farmers were using call services, and only 5% farmers were using soil health cards. And other farmers were using weather station or sensors. India have more than 121 million of agricultural land only, and most of them are marginal farmers. So these are the few problems we have identified. First is guesswork. Second is less productivity. Third is scientific knowledge gap, which is the scientific knowledge which is available in the inside the lab, and the gap between the scientific knowledge which is available in the lab and the farmer who is practicing on the field. We have came to know that there is a huge gap, and also the schedule based every year climate change, but sometimes the schedule based application which is same year on year, and the overuse of fertilizer pesticide. And to overcome this problem, farmers have also told us that what they want. First is affordability. The solution should be reliable. Second is they should be helped to increase the productivity and quality. Third is reduce their input cost. It should be easy to understand and not too scientific. Most of the farmers don't understand the data. They want directly call to action in their local language. If we told farmer that this is the 40% soil moisture, farmer will don't know what is 40%. What does mean by 40% soil moisture? So he should be told that this is this much water you should put into your soil, and it should be integrated. So there are a few technologies which is currently available. First is drones, then second is remote sensing, and third is on-field sensor. I'm focusing on the third, which is on-field sensor, basically IoT. So the sensor collect the data from the ground, where there are various sensors which collect the data from the ground. Then the data is sent to cloud platform like Amazon AWS, uh, uh, Microsoft, IBM Cloud. There are various also Google Cloud Platform. And then we do a data analytics part using the data, because getting the data is one thing from the field, and processing the data and providing call to action to the farmer is second thing. So then there comes the data visualization part. So let's take the example. If I have 10 acres of land, 10 acres of land. So and 10 acres in that 10 acres of land, we have different kind of soils. I have suppose I have two types of soil. So what we have done, we have developed a two model, which one is called the atmospheric model. Second is called soil model. The atmospheric, if 10 acres of land, farmer will just need a one atmospheric module. because it can cover up to 50 acres. So, and the second, which is called a slave node, which is used as which is soil module, which is connected to the master node, which is atmospheric module. So this slave node, which is soil module, so every soil has different composition. So they will need a different soil moisture sensor calibration, because every soil has different because of soil has different composition. So we need to calibrate sensor differently for each soil. So we will keep this different 2 to 3 soil nodes in the feed, and the soil nodes is connected to atmospheric node, and then the data is sent it to cloud platform using internet gateway, using GSM, Wi-Fi, or LoRa. So basically, our farm finder device will sense the on-field parameters using sensor. Then cloud platform will analyze or store the data, and will insight will be provided to the farmer in terms of advisory. So these are the few parameters which help us to provide the uh, insight to the farmer. Uh, uh, so these are the few parameters which include air temperature, humidity, air pressure, sunlight intensity, wind speed, wind direction, soil moisture, soil content, soil metric, water potential, and soil temperature and leaf fitness. So, the soil moisture placement, which is based on 2 to 3 things. First is physical soil texture, whether the soil is clay loam, or sandy. Second is plant or root growth stage, whether you cannot place the sensor at the same at below the soil for grapes have different root zone, or different length of root zone from the tomato, and farm topology where the farm is situated. So here I was explaining, you cannot use same kind of methodology for all the crops, because every crop has different because every crop has different root zone, or here you can see uh, we cannot just use one sensor. So we are using three soil water content or soil moisture sensor at three different root zones, because it will help to us to know the leaching part, and second is we'll exactly know where soil moisture is, if anywhere soil is saturated, or whether is some parts soil is very dry. So that helps to understand the soil moisture at the three different root zones. So why irrigation management is important? So without data, farmers are using too much or too less irrigation. Water leaching happens. If water leaching happens, then there will be fertilizer leaching will be there. So less quality produce, because soil also need root also need aeration. If you put too much water, then there is less aeration, and it hurts the health of root. It also reduces the productivity, affect the future productivity of the plant. With the data, we optimize the irrigation, improve production and quality, improve water use efficiency, less leaching will be there, and there will be healthy roots. So in terms of fertilizer management, without data, there will be soil degradation. Then schedule-based application will be there. As I earlier said, every year climate has changed, but the schedule-based application will be the same. Salt accumulation in the root zone, excessive application of fertilizer, and there will be fertilizer leaching. With the data, we'll know the exact real-time condition of the farm, and we will apply the fertilizer as needed. It will help to improve the uptake of the fertilizers. There will be less labor cost and better nutrient storage for the next season. So without data in terms of spray, there will be a panic spraying, excessive spraying. There will be a spray drift because of the wind, and there will be less coverage and efficiency. With the data, will save the cost, improve the coverage and efficiency, and reduce the spread. These are the few installations in the grape farm. So using the data from the farm, we can save more than 30% water, which is equal to 8 lakh liters of water per acre. Fertilizer saving is more than 20%, which is 12,000 rupees a year. Pesticide saving is more than 20%, which is more than 6,000 rupees. And increase the productivity and quality, which is equal to 23,000 rupees per acre per acre per season. So there are few challenges, opportunity. First thing is affordability. So as I said, we are working on the affordability. So if there are 10 small farmers who have 1 to 2 acres of land, so they can use atmospheric model, which is placed somewhere around their farms, and they will just need soil moisture module, which will connect it to the main module. So these 10 farmers will just need a one atmospheric module, and the atmospheric module will collect the data like air temperature, humidity, air pressure, wind speed, wind direction. And the other module, this module will be shared by all the farmers, and every farmer will need the soil module, which is calibrated according to his soil composition. So awareness is still we need to make more awareness about this technology, how this technology is helping to the farmer, because most of the farmers are less educated or small farmer. Adaptability is the issue is there, and ease of use. As I said, most of the farmers don't understand the data. They will need call to action in their local language. So this is from my side. Thank you, sir. Thank you, management team.
Thank you very much for joining us today, sir. We'll be opening for a Q&A session soon. There are a couple of questions in the chat already, sir. The first question, the one most important question about when you talk about IoT-based startups or IoT-based devices is more about the cost of the device. Because Indian farmers are being small and marginal, so cost of a device is very high for them when you see in multiple angles. How you are going to address this cost of the device? For them, sir, how you are going to pitch? How you are going to convince them that this is useful for them? We'll go in the same order, sir. I think Shailendra sir will join soon. Till then, Sham sir and Sanket can address the same. Please.
If you ask the question is being if you're asking this question, I would say that always cutting down the cost of the device so that it is made affordable to the farmer doesn't work, because as the other panelists have told, the sensors mainly the IoT devices work with the help of sensors, and the sensors has a higher cost when it comes to when we need higher precisions. So and there are obviously there are sensors low quality, low cost sensors, but that will not give the ultimate efficiency what the IoT or the automation is standing for. So I would suggest when it comes to the Indian scenario where the farmers owns small plot of land and has a issue with cash flow issue or purchasing, the farmers are with lower purchasing power. I would suggest the farmers to go for a sharing of resource or go for a collective farming. We are in fact consulting farmers or also promoting farmers to do joint farming. We have also, in collaboration with Managed CA, we have also published an explainer video explaining what would be the advantages of collective farming when it comes to the Indian farmer scenario. Yet another reason is cutting down the cost of the product to make it affordable for the farmers would make the manufacturer into the risk of getting eliminated by his competitor who is producing a higher quality equipment. At the same time, if you see this trend in the Indian agriculture sector, there are many huge multinational companies coming in to invest in the agriculture sector who would be doing agriculture on a massive scale, making use of information technology and also with the help of machines. Those huge mechanization process would ultimately is going to be a huge threat for the small scale local farmers or the poor farmers. So the 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 optimal suggestion that Butmore or we have is to suggest the farmers who has a lower buying capacity or purchase capacity to go to pull in the resource and go for a collective farming wherein the farmers will have the advantage of volume of scale. They will have the advantage of purchase power and also the selling power. That would be the my take on it, sir, because cutting down the product cost is actually going to be not worthy or useful in long run.
Thank you, sir. I'll just repeat the question as Sailendra sir just joined. The question was, sir, so how do you address the cost of IoT device? Generally, it is costly in nature when compared to other services, farm-based solutions or IT-based solutions. And the small, most of our farmers are being small and marginal. How you are going to deliver the message? That was the question that Sam was addressed so far. So you also can address followed base. After that, Sanket also will address. Please, sir.
Yeah, so there are multiple ways in which this can be addressed. The first biggest point is manufacturing on mass will definitely reduce the cost of the phone. Will reduce the cost of the IoT devices. One example can be the phone manufacturing, right? You can think of it as manufactured in this huge quantity. The cost has come down. The point is the adoption of IoT in India is still less, right? There can be two cases. One case is you go with the low quality sensors, whose accuracy you cannot depend upon the accuracy of those sensors. Second is you go with the quality sensor. So anything that is quality based will definitely come on the cost. My second point was there are different ways to address this IoT adoption or implementation of IoT across the wider spectrum of farmers. For example, there are ways in which you can implement the IoT application in pre-harvest for a village level, where farmers are not getting the information at the farm level, but at the village level. So depend upon what is the end application. But yes, manufacturing on mass can reduce the cost.
Thank you very much, sir. Sanket, would like to address the same? Do you have any point of view to share beyond this?
Sir, I can only say Mr. Shailendra Singh have addressed the manufacturer side of it. So I can just add this to that we can share, we can make a shared basis subscription model. So if as I said, there are if 10 small farmers are there, so they can share atmospheric model with them, and they will just need to purchase the soil module. So individually they will just purchase one module, and other module can be shared by all the farmers.
Okay, thank you very much. There is one specific question addressed to Sanket. Sanket, is it so? What are the parameters you are using for classifying soil type? And how is the process? It is semi-automated or fully automated? Can you please throw more light on that?
Okay, so it is fully automated. First thing, and second thing, to classify the soil types, we will do a soil testing for to know which type of soil your field have, and then we calibrate our sensor according to the soil type.
Okay, thank you very much. Sailendra sir, there is a question for you, and probably others also can address. So, do you have any tools at this point of time using IoT which are solving the problem of insect and pest management in warehouses?
We have not implemented anything in the warehouses. We have implemented it in the pre-harvest in the open field. So we have these IR cameras with the machine learning algorithms, or you can say image analysis algorithm. There's a source to attract this specific kind of insect, and using that you can count the numbers and you can find if the population is increasing or decreasing. So I think second question was on this thing, same thing. One of the application of this is insect counting. This is a real-time monitoring. This provide the alert, and this is done using the image analysis part. So we have deployed this thing in Rajasthan, we deployed this thing in Karnataka.
Okay, thank you, sir. So this is a question common for everyone. So is there any, how do you generally do a validation for the product? Let's say you say that we can give 15% yield or 20% yield. So how that this validation done, and can you tell what kind of an impact you can make for that field or a farm or a particular entity? You can now go in the same order, Shailendra sir, followed by Shyam and Sanket.
Difficult question. To be very frank, it's pretty much difficult question. People can say that the yield increases because of the new techniques they have used in the field, right? It can be because of the seed quality they have used, a better seed quality, or better package of practices that they have followed, or better irrigation techniques they have followed. There are a few quantifiable things, and then there are a few things which you cannot quantify. For example, water you can always quantify, that how much water is utilized. Okay, are the farmers irrigating properly or not? But there are few things which you can never quantify. For example, the yield. Is the yield better because of the better nutrient spray? Is the yield better because of better fertilizer spray, but fertilizer utilization? Is the yield better because of other parameters, right? But if a farmer follow all the practices, his yield is definitely going to increase, right? There's no magic in this. Agriculture is very difficult and very evolved thing, right? Nobody can do any kind of magic. But if farmer follow all the best package of practices, if farmer follow all the advice that is being given to him, his yield can improve. It can vary from 5% to 10% to 15%. In some cases, it's almost like double also. So you take an example of watermelon, right? Watermelon is a crop in which you do the irrigation properly and you maintain the soil nutrient properly. You can literally double the yield. So it's a complex question. Nobody would have the final answer. Yes, it can vary.
So thank you, Shyam.
Sorry, sir, I was my mic was on mute. Answering the question, how to what extent the yield could be improved or enhanced using the automation or IoT products in aquaculture. I would say we have done a couple of case studies. Like in general, taking two standard crops, farming it in, with the help of the smart farming, or the going for an high-tech farming with smart farming system from our system, and growing the same crop on a pond on the same unit area, on a different unit area. The results were like in case of seeds like tilapia, it was like 120 seeds to 170 seeds per 40 meter square is a number. Is the thumb rule number that is being provided for the open pond system. But when it comes to the RA system, it goes for up to 6,500 per 40 meter cube. So the productivity yield differs at the rate of 30 times. But I would say that is not, you can also do the RA system, like high intensity farming with without the automation solution or the automation hardware. The RA systems can be done without automation too. And that too also will give this the same level of output. But the question is, a slight amount of carelessness will make that number to zero. If you leave the system unmonitored unmonitored, where the thresholds of the parameters like ammonia, pH, or whatever shoots above the threshold value and remains for at least 2 to 3 hours, the mortality will range between 50 to 80%. So if we have an automation system that monitors and controls your farm in the most precise manner, the probability, the probability of failure or mortality can be cut down up to a great extent. Sometime and it could almost be made zero. But that is a question. It's like there is push. Mathematically, I would say that there could be a 32 times increase in yield. But if you ask me if this is possible without the automation system, yes, it is possible. A person will have to sit monitoring the system. And for instance, the 3 persons will have to sit in shifts when the system is running at full capacity, which is actually too much labor intensive. The probability of error would be higher. On the other side, you don't have to deploy any man. It's a zero-man system. You can do it. It would be cost efficient. And also, you would have the data from everything flowing into your system. So it would be the comparison with a system that follows a thumb rule. Human intelligence thumb rule, then the other would be the one with data and which is following a structure. And the second system would be more consistent. The first one would be less consistent. It would depend from person to person. So that's what I would say. What was the comparison between topics?
Thank you, sir. Sanket, how you are addressing this issue?
Sir, I will approach a farm level. I will take a farm level approach. So, if farmer is, I will take an example of grapes. If farmer have a grape farm with a 5-year-old grape farm, so what was his earlier productivity? What was his earlier experience on the farm? And what the difference came after we installed our device into the farm? So if he able to save after device installation, he able to save like 30% of water. Then there will be less leaching in fertilizer. So fertilizer cost will be saved. Third thing is less use of pesticide. If the I will take the efficiency of pesticide application is depend on other factors like wind speed or direction. If the wind speed is there, if the wind speed is high, so farmer will need to use more pesticides. So we are using delta T model, which is basically tell farmer which is right time to use, which is right time to apply the pesticide. So there will be a high efficiency from the pesticide. So I will just take our one of our farmer example. We compared their earlier data to data with after installing our device. So he is able to save about 20% of fertilizer cost, about around 20% pesticide cost, and more than 40% water is saved. And this also if you take the example of grapes, the grape are mostly the grape quality is 60 to 70% grape quality. It depends on the irrigation management. If you irrigate properly, if the roots are healthy, they will provide more nutrition to the fruits. So the fruits will be the food have better quality than last year. So this is how we have validated our product on the farm basis.
Okay. Thank you, sir. There is a couple of common questions on IoT for everyone. The first and foremost important, most of the places, especially rural places, there is a lack of internet penetration. How does this IoT device work without internet? Second thing, so how protective or how resilient they are for a weather changes or a rain or and all those things. So we can address in the same order, sir. Please, Shailendra sir, followed by Shaman Sanket.
Network issues are they are definitely network issues. There are a few ways to resolve that. For example, right now the penetration of network in India is quite good. If you go to even a remote location, you can at least find Geo working over there, right? But there is something called black spots or where there is no network. So there are a few ways to resolve that. One way is that you deploy a small device in that location. You transfer the data from that location to a location where network is there using wireless communication, and then where there is network, you can transfer. You can use a SIM over there. There are certain scenarios where there is no network for some time, and network comes and network goes. In those cases, you need to have something called local data storage and synchronization. So whenever network comes back, you transfer data back to the cloud. So this can be resolved using technical thing. As I mentioned in my presentation, in India, low Earth orbit satellite are not allowed. Means nobody is operating in India. If you go outside India, people are there who are using low Earth orbit satellites. They are even transmitting data when the ships are moving in the ocean. But in India, it's not possible. Second question is destruction because of some natural phenomena, or because of somebody asked if that animal destroy, what can be done. Right now, we have not thought of those scenarios. Mostly the location where we installed are mostly protected location, and you install this device on a SS pole. So there's definitely a safety. Yeah, if monkey come and start destroying the device, nobody can do anything. Monkey means, again, there are few things which you can control, there are few things which you cannot control, right? So these are my scenarios. At least we have came across couple of incidences where there's pilferage. People have stolen the devices inside a greenhouse also, right? So you cannot do much about that apart from having a fact that you can do the insurance of those devices, which again, that is not the biggest issue in front of us, right? So those are low priority issues which can be resolved once anybody scale.
Thank you, sir. Then Sham sir.
Answering the network connectivity issues, I would say in India, as Mr. Shailendra has already suggested, the mobile network connectivity in India is pretty good these days, and that when our devices are concerned, it has an onboard memory buffering system, wherein there is an onboard memory which caches all the data that the sensors or the device is communicating for a period of 24 hours, a minimum 24 hours. And if there is a network breakage or connectivity breakage within this issues within this time frame framework, within this time frame, the system would reconnect. Whenever the system reconnects back to the server, it uploads all the data which has got buffered in the caching. So that's how we have tried addressing the network disconnection issue. And coming to the other part, the threats from the weather or from animals. All our systems are designed for closed RA systems or biofloc system, high density aquaculture farming that often happens inside a greenhouse. So threat from animals is almost minimal, but threat from rodents is still there. And threats from sometimes our water quality monitoring systems are also deployed in the open pond, where it's subject to rain, wind, etc. But we have provided a protective shell, and our devices goes inside a metal box, so that the device ultimately remains protected from the quite a few of the external intrusions. But for sure, the human intrusions trying to steal things, or maybe a bigger animal trying to destroy the device, etc., are still there, which has to be covered by insurance. And in India, I think insurance is there for the agricultural products and the machineries. So that should be taken care using substantiated. The threat or the potential of loss should be substantiated using the insurance. And the other parts we have already covered. And I think I've answered both the questions, and I would like to the next presentee to answer.
Sanket, please.
So regarding network issues, Mr. Shailendra and Shyamlal have told us most of the things that we can have a local memory, that is onboard memory card for storing the data for period of time. Then the data, once the network is back, so the data can be transferred to the cloud. And second thing about the device protection, we have a GPS enabled device, but still, if someone disconnected the battery and stole the device, that there we cannot do anything. But we can provide a metal box for the to better protect from the outside weather and some kind of animal for the animal protection.
Okay, thank you, sir. We almost ran out of the questions, and Shailendra sir has addressed most of the questions actually in the chat. So I request everybody to go through the chat now again. We are opening questions to attendees. Anybody would like to interact with the or talk directly, would request them to raise your hand. Before that, I'll ask one final question before we ask them to raise their hand. So first, what is the average cost of per acre for your device, sir? They need to spend to cover 1 acre.
It varies again. Nobody would have the. I think nobody would have the very pinpointed answer. It depends upon the crop. It depends upon the area under cultivation. For example, per acre can start anywhere. Again, there are different models also. One way is that you are selling a device and then you are going for subscription. Other way is that you are going for the subscription completely, right? Rental basis completely. So these cost varies a lot. Anybody means there is no average cost. Again, for low cost devices, for sensors like temperature, humidity, and lux, the device cost can be anywhere between 10,000 to 50,000, depend upon the quality of sensor somebody is using, right? So there's a specific range for all the sensors.
Okay,
Yeah,
sir.
thanks.
Okay. Shyam, sir?
Sir, could you please repeat the question? I think the question was all about the
Device cost, sir. I was talking about device cost or average cost per acre in terms of farming. Because you are aquaculture based, probably you can talk in terms of return on investment. Let's say,
I
in,
I would say our devices are just designed for one pond. So it is irrespective of the size of the pond, but optimistically, I would say the size of the pond should be less than, because when we are doing intensive farming, optimistically the size of the farm should be less than 4 in 160 meters square or 2-dimensional area, or 160 meter cube. And it could also be deployed on a 1 acre open pond also. The cost for the automation system, as far, I would say exactly like how my previous panelists have told, there is no hard and fast thumb rule at all. Like it depends on from farm to farm, the purchase capacity of the farmer. The automation system, the upcoming automation system of our company would cost between 80,000 to 1 lakh rupees. But depending upon the type of sensors, number of sensors that has been connected to the system, the cost again is going to spike. And that there is no thumb rule. It all depends upon the farm design or the structure of the farm and the operations that we follow in the farm. And the cost is actually ranging between 80,000 to 4 lakh in between. That would be the best ratio.
thank you, Shyam. I will quickly round up with Sanket and we will start with the direct questions from attendees today. Sanket, please.
So it depends on whether you want atmospheric module or soil module. If you want both, the soil module will cost you around 15,000 rupees and atmospheric module cost you around 12,000 rupees.
Okay, thank you, Sanket. We'll move to the attendees. First, we'll have Gautam Mohan Pannusamy. Gautama Mohan Pannusamy. Sir, can you hear us?
Hi, good afternoon all. Yeah, I can hear you. Can you hear me?
Yes, please, sir. Please carry on.
Yeah, I joined the meeting a little late only. So yeah, basically I'm working as software engineer and part-time I'm doing farming in my own farm. So the thing I want to know is like whether do we have any devices, kind of system to protect the crops, paddies, and small trees from wild animals, especially like wild boar and deers, and yeah, mainly we are facing these issues
I
for
understand,
these
sir.
wild
We have a
animals.
couple of startups already working on the ecosystem where Manage is handling them as a knowledge partner.
Okay,
So please write to us. Our mail ID has been given where you have received. You write to us. We'll definitely connect to them.
okay, Sure.
I would request, any queries not related to the topic anybody is having, I request you to write to us directly so that we can address. I request all the participants, please keep a refrain from addressing to the today's topic, IoT-based startups in agriculture in allied sector. We'll move to the next participant, Pragya.
Yes.
Yes,
Hello.
Pragya, please.
Yeah. So my question is, I want to know about the accuracy of the products that were presented today. And another question is regarding the sensors. Are you making them in-house, or are you buying it from a B2B supplier in India, or you're importing those? So two-part question. Thank you.
When it comes to the IoT water quality sensors, we are importing. There is no production happening in India. Like the industrial, there is no production of industrial grade sensors, high quality sensors happening in India. Generally, we import from multiple countries.
Yeah, I'd like to add, first of all, I think sensors which are manufactured in India are mostly into research institutes like IIT Mumbai or IIT Delhi or even IC Bangalore. And nobody is manufacturing sensors in India because that is a highly complicated part. I know a couple of guys who are doing this thing in IIT Mumbai and IC Bangalore 3 years back. So I don't think that most of the people are developing sensor, and if the sensor are developed in India, they are mostly soil sensors which are resistive based. So it's more like a two probe thing in which you pass the voltage and you simply calculate the amount of voltage coming out, right? So which are not too much accurate. So I don't think, I know a couple of guys who are doing sensor, but if you go and ask them, can you give me the sensor to integrate it with my system? The answer will be no. Second point is, again, in the devices also, when I talk about the IoT device, it consists of two parts. One is sensor, which simply give you a voltage, and the other part is IoT devices. So I think all the people who are here will be focusing on the IoT devices and the firmware part and the cloud part, but sensor, no. Yeah, thanks. Over to others.
So same
Okay,
thing.
please.
Same thing with so we are procuring the sensor. We are just calibrating the sensor and the IoT device that we have designed out.
Yeah, and I need to add one more part. For example, just take example of temperature sensor, right? So temperature sensor comes in different varieties. There are a few contact-based sensor or RTD-based sensor, which are simply voltage-based sensor. But if you go to something that is capacitive-based, for example, you take example of Sensorion. So Sensorion sensor give you a sensor head, which still need to be put on a PCB. You need to add a specific schematic that is I2C based, and then you can utilize that, right? So it depends upon multiple factors. Soil sensor, yeah. So same thing. You need to work on sensors. You need to get them to a stage where you can start utilizing the output coming from them, and then integrate them to your hardware.
Excuse me. I think there was a question which I have not answered. Somebody has asked me, Kamesh has asked me that how often do you calibrate the pH, EC, and DO sensors? Is there a schedule for calibration? Yes. Generally, it's required that you clean the sensors periodically, at least once in 2 weeks. Just check the sensor if there is any algae or dirt deposition happening inside the sensor. Clean it manually. And when it comes to the calibration, ideally the industrial sensors are to be calibrated once in 6 months or 6 to 8 months. Once in 6 to 8 months, the sensors leave the factory, which leaving the factory would be calibrated. You do not have to touch it for the first 6 months, and after that you have to, you definitely have to calibrate it for continued life. And for a long-term life of the sensor, make sure that the sensors are cleaned periodically, regularly, based upon the water quality. Thank you. I think, sorry that I had to intrude. There was a question which I did answer. Sorry. Over to you, sir.
Would
No
you
issues, please.
just one follow-up question? Would you be able to tell some name of the companies as well that are producing high quality sensors that we can import from?
YSI.
Sorry?
YSI.
YSI. Okay, thanks.
So it is to mention to all the participants that all the three speakers' contact details, mail IDs has been shared in the chat. You need any information which you feel cannot be asked in the forum, or you want any further interaction related to their products or services. For example, there was a company talking about, there was a participant talking about they want to have interventions related to CSR activities so that they can support your device through CSR activities. I believe already Sir mentioned that they all, Sir mentioned that they're already working in a couple of CSR initiatives. So these kind of things, any of the participants want to take forward next level, so you can write to them. All the mail IDs have been given here. Thank you. We'll move to the next one. Gunwant. Gunwant was raised there. His hand was raised. It's not there now. So I request anybody is there, please. So no, if no further questions, we'll probably end little early today. With little justification being holiday also for today. Thank you. So thank you very much. We would like to thank all our attendees today. Despite holiday, there are more than 130 people are here. I mean, approximately, it shows the commitment from their side as well as all ours. I would like to thank heartfully for all our three speakers today for turning up and despite holiday and covering end to end what they are doing, how the sector is working. So and complemented by the question and answer session. Would like to thank our Managing Director General, our Director Agriculture Extension, Sarandar sir, as well as our entire team members, Shashank being here despite all day. Thank you, sir. Thank you very much. One note you need to take from January 1st onwards. Our Saturday webinar series, we are truncating the time from 2 hours to 1 hour, so that we can be we can address to the problems more in a more precise manner. Thank you very much. Have a great day ahead.
Thank you.
Thank you all, and happy Christmas to you all.
Merry Christmas.